Hey, and welcome back. Today we are going to animate our player character and learn about event sheets. Let's get going. Before we start to animate anything, we need to think about what we want to animate. Looking our player currently, it can run and jump. So those are the things we might want to animate. Also, idle animation is something that would be nice. So let's make those for now. If we decide to add new gameplay elements, we can animate them later. To animate, we need to open the sprite editor by double-clicking our player. Now, on the right side, there are animation and animation properties windows, and at the bottom is the animation frames. First, let's add the animations we want to make. By right-clicking the animation 1, we can rename it to an idle. Here, remember how you write these. Construct is case sensitive when using animations, so remember if you use uppercase letters. Next, we right click right under the idle animation, so we can add a new animation. I'm going to call this run. And finally, I add the last animation called jump. Now that we have our animations defined, we need to create all the frames for them. To add a new frame, we right click on the animation frames window, and we can choose either adding a new frame or duplicating the last. Personally, I prefer duplicating the last and modifying it rather than creating an empty frame. Then we just create all the frames for all the animations. Again, for the sake of the length of the video, I'll make them really simplistic, but you can make them as complex and good looking as you want. One final thing we need to do is to check the loop option in the animation properties and do it for all the animations. So this will help that the animation doesn't stop when it reaches the last frame. Now that we have our animations, we can try to play the game. Well, our player animates, but it doesn't change animations depending what the player is doing. To fix that, we need to make some logic in the event sheet. So, if we open the event sheet, we can see an example at the bottom of how the logic will look. There you can see one event, which is basically one part of the logic. One event basically consists of two parts, conditions and actions. To put in plain English, all the conditions are if words. So in this example, the condition reads as if bullet is on collision with an enemy. Then the actions are all the things what will happen when the condition is met. So the whole event reads as if the bullet hits an enemy, we destroy the enemy and the bullet. Don't worry if it seems difficult to understand. I'm sure it gets easier later when we have used them a little bit. So the first thing we want to do is to change the animation to run when our player is moving. We do it by pressing the add event text on the up left corner. It opens a window where we can choose our conditions. First, we need to choose the object that is the subject of the condition. So in our case, we want to check if the player is moving. So we choose the player as an object. Then construct will give us a lot of options for different conditions, but we want something called isMoving. Once again, construct will provide us with a small explanation how the condition works. After the condition is added, we can add an action by pressing Add Action text in the event. Again, it works the same as adding the condition. First, we choose the object that is affected by the action. Then we find the proper action that we actually need. This time, we are looking at something called Set Animation. By double-clicking it, it opens a new window, and there we can define what animation we want to set. Between the quotation marks, we need to write the name of the animation that we defined earlier inside the sprite editor. Here you need to carefully write it exactly the same way as you write it in the sprite editor. I will write it as a run with uppercase R because I wrote it the same way in the sprite editor. If I would write it with small case r, it wouldn't work. This is the meaning of the case sensitivity that I talked about earlier. After this is done, we can leave the from option as a beginning, as we want the animation to start from the beginning. Now we should have a working event, and we can test it by running our game. Well, when we start to move, the animation changes, but if we stop, the running animation will still continue. And that is because we never change it back when we stop moving. Gladly, it is really quick to implement. We can just copy the previous event by clicking it once so it's active, and then pressing Ctrl+C, Ctrl+V, so basically copy and paste. Next, we press the condition once to make that part active. Then, by pressing I button on the keyboard, we can invert the condition. So now there is an X before the condition. It reads as when player is not moving. Lastly, we need to change the animation that we set. That can be done by double-clicking the set animation action and changing the name of the animation to idle. Finally, let's test if it works. Well, great. Now we have working run and idle animations. But there is still jump animation left to implement. And that will be a small challenge for you to implement on your own. Pause the video and try to do it. Were you able to do it? Well, let's check it out. First, we need to add a new event. Then we choose the player as an object and find condition called isJumping. Well, now we have the correct condition for that event. Next, the action is basically the same as before, but with different animation name. So we press new action, player, set animation, and write jump. If we run our game, now our player should animate properly, and it looks like it does. But there's still one glaring problem. If we start to walk to the left, our player still faces to the right. There are multiple ways to do it. We could, for example, check if the X coordinate is bigger or smaller now than the last frame and turn our player based on that. It would work, but one big problem with it is that if we run to the wall, player starts to twitch uncontrollably. The other way, and the one we are actually going to use, is to read input from the keyboard and turn our player based on that. We can do it by first adding keyboard to our project. It is done the same way as any other object in our game. So let's go back to our layout and right click to insert a new object. Next, we find object type called keyboard in input section. Now it should be added to our project and we can read the input in the event sheet. So let's go back there and make a new event. This time we have a keyboard as an option to choose as our object, and that we will choose. Next, we choose a key is down condition. Again, new window opens where we can define what key we are reading. Let's click the click to choose button, and when the new window opens, press the left arrow button. Then we can press the OK button. Now we are reading if we press left arrow button, and next we define what will happen when it is pressed. We want to mirror our player when we move to the left, and gladly there is an action called set mirrored. So now we need to choose if we want it to be mirrored or not mirrored. Well, of course, in this case we want to be mirrored, as we are checking if we move to the left. Now, before we test our game, we need to add other events to set our player back to not mirrored when we move to the right. So we can do it again by copying previous events and changing the key to right arrow key and mirrored state to not mirrored. Now we have properly working player. Let's test it one final time. And it looks like everything works as we thought. That's everything for this time, and I see you in the next episode.